Hi guys, sorry that I'm not there. We're going to be doing skill 2 today. I hope proportions went well for you guys yesterday and that you have a pretty good grasp of how to solve those. Today we're going to work with functions. We're going to talk about what makes something a function. We're going to check to see if it's a function. We're going to evaluate a function. I think you've probably done some function work before in Algebra 1, so I don't think this is going to be, again, too challenging of a lesson. Remember, we said we're going to start off pretty easy with some regular Algebra 1 review, and so this is what I would consider probably another review lesson for you, hopefully. We're going to start with the definitions there. So first one up there is a relation. A relation is any set of ordered pairs. So relation is the most generic version of what we're looking at. Anything that has x's and y's, inputs and outputs, is considered a relation. Nothing special about it, just very general. When we want to be more specific, we talk about something being a function. So if you skip down to the fourth one, function assigns a unique range value for every domain value. So there is something very specific that's happening that makes something a function. Going back up to the definition for domain, domain is a set of inputs. Over there you can see it says inputs, it also says x values. So domain are your x values, your input values, or your domain. So three different words mean the same thing, domain, input, and x values. Underneath there you have range. So again, three words, range, output, and y values. Range, output, and y values all describe the same thing. What I want you to realize is that you only get to use the terminology domain and range if you're talking specifically about a function. A relation, remember, generic version doesn't get the use of the words domain and range, just the function does. And then underneath there, which I think will be the most complicated part of the day, is that y is equal to f of x. This f of x, that's how you read it, that is called your function notation. So you won't see y's anymore in a function notation. You will only see f of x in function notation. And you'll see that later on at the end of the lesson. We'll talk about evaluating in function notation and how to do that. Just so that you know, f of x is going to show up as an answer. So you could say f of 2, f of 3, f of 4. And when you do that, you're replacing that x with values, and so you're inputting whatever that is. So if I say f of 4, I would take 4 and I would plug it into the equation because 4 is my x value, which is the same as my input value. But we'll get back to that at the end of the lesson. All right, so how do you determine if a relation is a function, right? So all of these are relations. That's the generic name for them all. We're checking to see if there is a specific version of a relation called a function. So there are a couple of different ways to check. You can check your input values or your domain values and make sure that none are repeated. You can look for a graph. Do any of you guys remember what you're looking for a graph? It's a certain type of, we call it a test. Okay, in parentheses behind there, analyze the graph of a relation. You might want to write in here in parentheses the words vertical line test. That's what you're using when you look at a graph. And then the third version is a mapping diagram. So what you can do is you have a list of your input values, you have a list of your output values, and then you draw arrows from inputs to outputs. So you can see how that goes. Okay, let's go ahead and look at the example that we have on there. It says check that no domain values are repeated. So you've got set A, 2 to 3, 3 and 6, 2 and 5, 4 and 9. Set B has 2 and 3, 3 and 4, 4 and 3, 5 and 3. Now, you can already see the answer, which one is a function and why is set B. This is what I want you to look at. Do you see that 2 is an input and it goes to 3? But over in your second ordered pair, 2 is an input and it also is paired with 5. So what you're looking at is that you have an input value of 2 and it has two output values, both 3 and 5. And so that's what's making it not a function. Okay, set B. A lot of students struggle with this. Do you see that 3 is an output here, 3 is an output here, and 3 is an output or a y value there? So you have 3 repeated. And so a lot of times students will tell me that's not a function, but that's not right, because you're not looking at the y values, you're looking just at your domain values or your x values. So your x values are the ones that matter, okay? Go ahead and grab your whiteboards, and we're going to do a whiteboard problem together. All right, so you've got this, it's -2, 3, 3, -2, 1, 3, and 0, -2. So the question is it a function or not? If it is a function, you can list your domain values here and your range values here, and then you're going to do that for that second one. So go ahead and pause the video and take I don't know, it'll probably take you maybe 30 seconds to a minute. Answer whether it's a function or not. If it is a function, list your domain and range values. All right, go ahead and pause the video and try that. Okay, let's go ahead and check your work on the first one. So if you look at your x values, you have a -2, a 3, a 1, and a 0. Do any of those values repeat? They do not. That would make this yes, it is a function. When you list your domain values, you would list your x values. So -2, 3, 1, and 0 are your domain values. Your range values are your y values. So 3, -2, and that's all you would list. When you list your domain and range values, you don't repeat numbers. So your range values are simply 3 and -2. Don't repeat the other ones. All right, if you look at the next example, inputs are 3, -2, 3, and -2. Because both the 3 is being repeated and the -2 is repeating, that is not a function. So you would just simply say no, and then you're done. Remember, because domain and range only apply to functions, so if it's not a function, you don't have to list domain and range values. Those are simply just exit values or input values. Okay? All right, go ahead and find your notes. We'll go back to those. Okay, so the second way you're going to check to see if something is a function is you are going to look at the graph and analyze it. We're going to use the vertical line test. So there's that blank you're going to fill in. I told you to write it above, and here it is again. Vertical line test. To determine if a relation is a function, here's the rule. If a vertical line passes through no more than one point at a time, then it is a function. So every vertical line can only pass through one point. Every vertical line can only pass through one point. So here's your picture. Now the graph that you're checking, or what you're checking to see if it's a function, is this curved graph. Okay. If you're wondering, that's the graph of something that is cubic, or what we would call x to the third power. That's the graph of something to the third power. But anyways, so you're going to go ahead and draw these vertical lines up and down, and you're checking. Do any of them ever cross that graph more than once? And the answer is no. So that is a function. Look underneath here. The second one, if I draw a line here, it's okay. It only crosses the graph once. But if I move over here and draw a vertical line, notice it crosses the graph 1, 2, 3 times. So that makes it not a function because it does not pass the vertical line test that we've talked about. Okay. Again, go ahead and take out your whiteboards, and we're going to try a couple on our own. Okay, so you've got your whiteboards. You've got six different graphs to look at. So it says state whether each graph is a function or not. So these all represent relations. The question is, are they functions? Okay, so go ahead and take, again, it shouldn't take you too long. You are drawing vertical lines, and you are checking to see if they cross more than once. If they cross more than once, they're not a function. If they only cross once, then they are a function. So go ahead and pause the video and give everybody a chance to answer for those 6 individual graphs. Okay, first graph. If I draw vertical lines through this circle, that is going to cross twice every single one I draw, so that is not a function. This graph is a straight line, very simple and straightforward. The answer is yes, that is a function. This one is an absolute value graph, and again, the answer is yes, that is a function. Underneath here, vertical line test for this graph, yes, it is a function. This graph, let's see, what is that one? Fifth one, as you draw vertical lines, notice that they are crossing the graph twice. So that makes that not a function. And this one, again, it's a little bit maybe harder to see, but if you draw a vertical line through one, basically, you're crossing the graph twice. And so that makes it not a function. Okay. Go ahead and find your notes, and let's transition back to those. We have a different type of graph to talk about. All right, so we have another type of graph. Let's go ahead and fill in these blanks, and we'll talk more about it. The graph to the right continues from -3 to 5, so it goes all the way, except at x equals 2, this is what we call a break in the graph. So there's an open circle at 2, 6, and there is a closed circle at 2, 4. The open circle means the point is not part of the graph. The closed circle means the point is part of the graph. One open and one closed means that x equals 2 only has one value. So yes, it is a function. Well, let's back up and continue having a conversation. So for future reference, when you get into pre-calc, you will see graphs like this more often. These are called piecewise functions. Piece, right, there's parts of it, so there's two parts to the graph, and so it's called a piecewise function. The open and closed circle is definitely a conversation we've had this year. If you think about graphing inequalities on a number line, we did open and closed circles. So open means not included, and closed means included. So when you go to check to see if this is a function and you do the vertical line test and it's going up and down, right, everything is good. When you get to here, the big question is right here at 2, where there's a break, is it a function? Well, right here, the point at 2 is included, but at here, because it's open circle, it's not included. So that makes it a function. What would make it not a function is if they were both closed circles, because that would mean that 2, the x value of 2, has two values, 4 and 6, if they were both closed. But because one is open and one is closed, that does make it a function. I think you're going to see some of these on your homework, so make sure you're looking very carefully at the details of whether or not you have open or closed circles. All right, keep going down in your notes. We're going to talk about mapping. Mapping is similar to just looking at ordered pairs, x's and y's. It's just maybe a little bit more helpful if you're a visual learner. So how the mapping works is that these are your domain or x values, these are your range values, and you're just following. So that means that 2 is paired to 6. If you were to write it as an ordered pair, it would be 2, 6. 5 is paired with 15, 10 is paired with 30. So notice it's 1 to 1. For every input, there is one output. So function, each domain value has one range value. That's fine. When you look at the second example visually, I think it's very obvious. Look at this 15 down here in your inputs. 15 goes to 7, 15 also goes to 9. So that makes it not a function. It has two outputs, okay? So you're really, again, looking for two x values. How to evaluate a function. So we were talking about this at the beginning of the lesson. This is function notation. It says, what is the value when x equals 6? You take 6 and plug it in for x there, and plug it in for x there, and you solve it. F of 6 equals 2. And then you can keep plugging in different values. So you can plug in 3, -3, 0, 7.5. So you notice in all of those x's, you're just plugging in different values. All right, I hope you're feeling fairly confident about what's going on with functions. Yeah, I hope your homework goes well, and hopefully I'll see you again soon. Bye, guys.